All right, so let's start talking about your undergrad. So you enter undergrad just like me. I was very sort of science is the only way to discover truth. The truth that we're talking about in these classes, like these are the laws of nature, the underlying code of the universe, right?
Yeah.
So how long does that last for you, and how does that sort of get deconstructed initially?
So it kind of comes about actually almost chronologically from a historical perspective. So one of the first things, so I had to begin to refine my position a little bit. And so the first thing I got exposed to was positivism, which is this idea advanced by Karl Popper, amongst others. I should say, as I'm talking about this, I'm not an expert in philosophy. I don't have a degree in philosophy. So as I'm saying this, I'm going to try to give citations for folks if they want to read more, and know that you're hearing this from an amateur. But basically, positivism is an idea which I actually think most physicists never get past in the philosophy of science, which is that something is science. And so here we're talking a bit about what is science, right? That was the first thing I had to figure out when I got to undergrad, is what are we doing in science exactly? And positivism is basically the idea that, and post-positivism is the idea that science is wrapped up in this idea of falsifiability. So if I make a statement and that statement is falsifiable, then that statement is a candidate for science. That's sort of the positivist perspective. And I was pretty happy with that, because that allowed me to maintain basically my entire worldview. And it just gave me a bit more of a refined way of talking about what science is and how it functions. But in philosophy of science, that view is considered, I think, quite outdated by most people. And so one problem with this worldview that was presented to me is that it's not really self-consistent. Like, is that statement in and of itself scientific? Can you falsify the statement that science is about claims that are falsifiable? And the answer is no.
But it seems to me like the definition of science is subjective, and then you just move on.
Well, yeah, that's kind of the move you have to play. You basically have to say, well, I'm not doing science to get myself going. I define science in a way that isn't part of science. But now you run into a real problem if you're a scientific realist, because if truth in the world is mediated completely by science, and the foundation of your definition of science isn't scientific, then is your definition of science admissible as a kind of truth in the scientific sense? And the answer is no. So you kind of have to accept the fact, if you sort of follow this line of reasoning to its conclusion, if you sort of say, well, okay, I think truth comes from science. What is science? Science is falsifiable claims. Okay, but that claim's not falsifiable, so it's not true in a scientific sense. So the foundation of truth is a claim that isn't true. And you run into this kind of contradiction, and so positivism begins to sort of fall in on itself. And sort of what comes in its successor, and I'm kind of now describing this as I describe this. I'm kind of describing my own journey here. The successor argument, one of the successor arguments I was introduced to, is from this guy Quine, right? And so Quine, great philosopher of science, and Quine basically says, you have a mesh of beliefs. You've got a big mesh of beliefs about the world, and these beliefs connect onto each other. And the more embedded a belief is in your web of beliefs, the more likely you are to hold on tight to it, as opposed to a belief that's at the periphery. So for example, I'm pretty sure I'm 28 years old. I'm pretty sure I was born on May 29th, 1994. I think that was my birthday. And there's a whole bunch of other facts in my life that kind of corroborate that belief. So I'm really disinclined to release that.
Yeah.
But by contrast, for example, by contrast, I think that Quine was doing all this work in around 1950, but I'm not really that sure about that. And if someone came on and challenged me on it, I'd be happy to just abandon that statement. So that's kind of an example of how the web of belief works. And what Quine wants to say is that that's kind of what science is. Science, there's a kind of nucleus of things that constitute science, and in part that means experimentation, but it also means building a coherent story that links the experiments together. It means making predictions and retrodictions, and all of these things are sort of part of science. And so there's a kind of core of science, and then there's a kind of penumbra of science. There's a kind of bunch of things that are kind of they're kind of science, but they're not really science. So Quine's account of science, this definition of science, does allow us to kind of preserve the belief, if we want to, that science is the arbiter of reality or truth in the world. Believing in Quine's view lets us say, okay, science is the arbiter of truth and reality. The boundaries of what science is are a little bit fuzzy, but there are things that are at the core, and those things really do define what the facts of the world are and what the truths of the world are and how they're all related up together. And that's kind of maybe the next another stage on this journey a little bit.
So that does seem like, relatively reasonable. I mean, starting from a very subjective starting point and then defining how you're going to truth seek. I mean, like, that's not like in a way that, I mean, you can build consensus with a number of folks that's a good way to truth seek. Is there some glaring issue with that I'm not seeing?
Well, there are a couple of interesting things about this worldview. So one thing about this worldview is that it still allows us this idea, and anyone who's done statistics will be familiar with this, but you never prove anything true. One conclusion that you can draw from that, you only ever prove that something isn't false.
Yep.
Okay, so that's kind of an interesting observation. And then you can get into some kind of strange conclusions. So there's this idea of Quine's that comes out a bit later about the indeterminacy of translation. And basically Quine says that on a certain level, you can never really translate any sentence to any other sentence, or even be sure that when you hear someone say a sentence that you even know what they mean by that sentence. You can behave accordingly. You can hear someone say a sentence to you and you can behave in a way that both you and the person who just spoke seem to kind of agree is reasonable. But can you really be sure that you knew what they were saying, that you understood what they meant? And the idea here is that if you create a sort of pattern of language that's complicated enough, or rules for language that are sufficiently complicated, you can kind of derive any meaning from any sentence. And there's no real way of being sure about what the true meaning of a sentence is. And it's kind of just a matter of practicality that we don't worry about this fact. Somehow it just happens to be the case that when I say something like, could you pass me that glass of water, to someone else who speaks English, and they know what I mean, and they pass me the glass of water, and I say, oh, excellent, I've communicated with them, they understood what I meant. That's all I really needed. I just needed the water. So it doesn't matter so much whether or not they really knew what I was saying. And Quine's observation is that you can't really ever be sure that they knew what you were saying. All you can know is that they gave you the glass and that's what you were expecting. And that's kind of a metaphor for the scientific process. I can go out and I can make measurements and I can say, yeah, those measurements are consistent with, quantum electrodynamics, and it all checks out and it works. How can I really be sure the universe isn't trying to trick me, that there aren't some very, very complicated laws that are really bizarre and the laws just conspire to give me exactly the results I would expect for quantum electrodynamics over the last, 100 years or so since quantum electrodynamics.
What do you mean by that? That seems a little out there. So let's clarify that statement a little bit. They could be time-like in a way that we don't understand, for example.
Yeah, maybe there's a time dependence to all the laws of nature that's really complicated. And I don't know, maybe 3 years from now, all of a sudden, all the physics that we understand totally change. All the laws of nature will be different, will be repulsive, and all of a sudden, what happened to our precious laws of physics? Do we still believe in those laws? Suddenly, no one thinks that that's the sort of counter argument to that is, well, we'll see. It hasn't happened yet, and scientists, I think, take a very practical view of this question. If you speak to people who actually work in physics, they'll say, "Who cares?" I'm paid to go out and explain why this material is conductive in such a way that we can manipulate its conductivity. And I did that. So, what are you talking about when you say, well, what is the material actually doing? Are there actually electrons? Like, these questions just aren't really relevant because physics is this, today at least, and this wasn't true hundreds of years ago, but today as a physicist, your job is to make predictions that can be checked in experiments that can be used to intervene in the world in a way that's kind of predictable. And as a scientist, you just don't really worry too much about, quote unquote, what's actually, it's not even clear that you can define that concept clearly, like what's actually going on versus what we observe in every circumstance to be going on.